Okay. So the first thing, in this class, there's actually going to be there will be math, but this first lecture has a lot of like definitions and things like that in order to kind of get us all acquainted and make sure we're all using the same language. So just realize that today it's going to feel like a lot of words, but that's not how every class is, okay? So the first thing let's talk about is just basically what class you're in and why we take this class. So engineering economics is about decision making. Okay, and what I mean by that is that the business world, they may not always mesh well with us engineers because we are trying to optimize the entire picture as a whole, whereas they might pick like what feels good. We're trying to be the objective advisors for them, even though, let's say you're a startup and you just like want to do something some way. We're there to be like, whoa, this is actually the better move to make. Okay. So, the business world may not always mesh well with engineers as we optimize and look at the entire picture as a whole, whereas they may pick what feels best in the moment. Okay, and it is our job to advise based on actual analysis. Okay, so let's talk about time value of money. So what do you think of when you think of the word interest?
More money on top of the money you already borrowed.
Okay, and what's the purpose of that?
So your creditor or your loan company can make more money.
Very good. Yeah, it's like, I mean, why else would they loan you money, right? Other than it being an investment and being worth their time, because in the end, after you pay them back, they'll make some money off of it, right? So it is the money that you pay, the money paid to borrow, or you could look at it as the money earned from an investment, depending on, what side of this deal you're on. Okay, so if interest is high, who is that good for?
The lender.
Very good. Good for the lender, but bad for the borrower. And vice versa, if interest is low, then that is bad for the lender and good for the borrower.
Hi, Professor. I actually had a question related to how you have your Zoom setup.
Sure.
Um, since you only have, oh wait, never mind. I see your two accounts. Okay, because I thought you only had one account using both your PC and iPad, and I thought that was really interesting. Never mind. I'm sorry.
I impressed you. No, yes, I'm signed in on 2 devices. So, and you might find that that will be what's required for you as well as a student. Sometimes it's just too hard to view everything on one computer, especially, for example, let's say you're signed in on Zoom through your phone, but then you have to go submit your quiz using your phone. So usually when you do that, it turns your camera off and, things like that. So some people, like when we take our quizzes, they'll use their computer to view the quiz, and then maybe they'll use their phone to submit the quiz, So sometimes people are signed in on 2 devices. And when that happens, I need you to rename one of the devices. Okay, here's the other reason. Sometimes you're signed in on a desktop, which doesn't have a camera. And then you have to sign in with your phone to use it as your webcam. Okay, so that's another way to do it without having to check out a webcam from the school or buy a webcam. You can sign in on your desktop to view everything, and then sign in on your phone to use it as a webcam. And so when you do that, you would need to rename the desktop as like no camera. Like, so I understand, because before we take a quiz, I always make sure everyone's camera's on. So I'll be like, why isn't your camera on? Turn your camera on. We're all waiting for you. And then it'll be because, that device doesn't have a camera. So rename that device as no camera, and then rename the other device like with your name so that I know who it is. Kashif, you had a question?
Yes, Professor. So you mentioned about the quiz. So is that going to be online quiz, or it's going to be on paper? You're going to be sending us a paper, and we're going to write down on a paper and picture it and submit
So it'll be presented,
or it's going to be on
like
camera
this.
online.
Yeah, it'll be presented like this on my screen. You'll see it, and you'll have to write it down.
Okay.
Yeah.
And what is that going to be? Theoretical MCQs, fill in the blanks, or what kind of quiz is
Oh,
gonna be?
it's like a problem statement, and then you would have to work it out. So it's like, I guess you would call that free response, right? You have to work out a problem. Yeah, it's not like ABCD or anything.
Okay.
Yeah. Other questions?
No.
Okay. So one more thing I want to define is APR, which stands for annual percentage rate, i.e. interest. Okay, so if someone gives you the APR, they are referring to the interest. Let's define some more things. So there's a thing called a fixed cost. What do you think that means?
Fixed costs are typically costs that are unavoidable, having electricity, stuff like that you have to operate a company.
Okay, so it could, and let me be clear about all these definitions, is they're not mutually exclusive. So one type of thing that, like Andrew just referred to, could fit into a few of these categories. So a fixed cost, in terms of the specific definition, is something that is unchanging regardless regardless of the output. Okay, so
Like rent.
yes, so rent, it doesn't matter how much you produce or how little you produce, you still have to pay rent. So that would be fixed. Yep. However, like your electricity would not be fixed potentially. Like if you are producing more and using, like your machines are using more energy, then your electricity bill would go up. So that's not a fixed cost because it does change. Okay, so by contrast, a variable cost is something that does change. So a variable cost, it does change based on the output. So if you need, if you spend X amount of dollars to create one widget and then you produce 100 widgets versus producing 1,000 widgets, obviously that cost of producing is going to change based on how many things you're making. Who knows what a first cost is? Well, I don't want icons. Who knows what a first cost is?
Is that your initial setup?
Yeah, Corey, is that what you're going to say too?
Yeah.
Yeah. Yeah. So the first cost is like your initial investment, I would say, like right at the beginning, what you have to pay. Now, in very basic terms, you could look at it as just like, what did I buy my iPhone for? Like what the cost was my first cost. So then you have something that is called operations and maintenance cost. But because it's such a mouthful, we usually just call it O and M. So when we say O and M, that's what we mean. And that is something that is a recurring cost. So it's something that happens over and over again, like it's like your monthly bill, right? Just to keep the lights on. Operations and maintenance. We also have something called the salvage. And does anyone know what a salvage is?
Salvage is like what you can get for equipment that's past its used date.
Very good. So it's a trade-in value. And so again, I like to use the example of an iPhone. So maybe you bought it for $1,000 just last year, and then you can go upgrade, right? Their upgrade program, you can go get the next iPhone and you trade it in, and they usually give you like a credit, right? They'll give you like $500 or something. So your first cost was $1,000. Your trade-in value was $500. That's salvage. Now, you wouldn't really argue that that iPhone is at the end of its useful life after trading it in a year. But even so, you could have like an iPhone 6 and you could go try and sell that on eBay and it would have some trade-in value, right? You paid a certain dollar amount for it at the beginning of its useful life. That was its first cost. What you can now sell it for after you're done using it, the trade-in value is its salvage. What do I mean by a like direct cost?
Would a direct cost be a cost that's only directed towards whatever that single output be? So if there was a specific machine that was required only for that output and it needed to be repaired?
Okay, so I would say it's directly related to what your operation is. So it would be like labor or materials. By contrast, an indirect cost is something that's not directly related to what your operation is, but you still have to pay for it, such as utilities, insurance, etc. This one's my favorite one. What's opportunity cost?
The cost of going one direction instead of another.
Very good. So in high school, my friends asked me to go to the lake all the time. I had to say no because I chose to stay home and do my homework. Okay. I missed out on going to the lake. That was my opportunity cost. But my friends missed out on getting those A's because they didn't do their homework, right? So any choice you make, there's always an opportunity cost for not having made the other choice. So it's the benefit that you lost by choosing the alternative. All right, let's talk about simple versus compounding interest. So, simple interest is the interest that people might think about if like they're laymen, they've never taken an economics class, they like kind of think they have a concept of interest where they understand that it's money that you pay on what you borrow, but they think that it only applies to the initial amount, right? They think that it, like you would only pay interest on the initial amount, which of course in real life is not that common. So what I am saying is if you had some initial amount P, they think that you just pay all of P plus some interest factor times the amount of years to get F. So P is your initial amount. I is your interest rate. N is the number of periods. So it could be like months or years. And F is the final amount. Okay, so the second way is compound interest, which is way more common. And this is where you pay interest on whatever your remaining balance is. So this is like your credit card. If you don't pay down the entire balance, right, the next time you're going to owe interest on that. each time you're owing interest on whatever's remaining. So you pay interest on the remaining balance, which of course is much more common. So in terms of equations, we're saying it's not I times n, it's I to the n. Okay, and each letter is the same. Questions about that so far? Okay, let's do an example. So, number 1, let's say you lend your friend $1,000. She is to pay you back in 3 years with a simple interest. So they would have to tell you they mean simple, with a simple interest rate of 10%. How much will she owe you?
Is 1,300 too simple of an answer?
No, we are talking simple interest. So we are using this equation F equals P times 1 plus I times N. So what do we plug in for P?
1,000.
1,000 times 1 plus, what do we plug in for I?
10%.
10%, which is 0.1, so to be careful, always put it in decimal form. And then what do we put in for N?
3.
3. Okay, so when you punch that into your calculator, what do you get?
1,300.
1,300. So you were not incorrect. $1,300. That's based on simple interest, though, which, like I said, not very common. So for number 2, let's say that you deposit, and I'm going to use basically the same numbers so that you can see the difference. Let's say you deposit $1,000 in a bank account, which pays you 10% compound annually. Okay, how much would you have after 3 years? How much would you have after 3 years? So first of all, which equation should we use? The first one or the second one?
Second.
The second one. Why?
Is it compound interest on a simple one?
Right, because this is compound. So we're going to use F equals P times 1 plus I to the N. What's P?
1,000.
What's I?
Again, 1 or 0.1.
0.1. What's N?
3.
Plug it in. What do you get?
1331.
Very good. Notice the difference. Right? They're not the same. So if you only pay interest on that initial amount, your final amount is 1,300 versus if you pay interest on the remaining balance each time, now it's 1,331. Okay. One last thing I want you to know before I let you go is that the beginning and end values, maybe you can chew on this, the beginning and end values are equivalent. By virtue of the time value of money. So what I mean by that is if someone offered you $1,000 today, or they offered you 1,331 in 3 years, you should be indifferent. You should not care either way because they're equivalent. They're worth the same by virtue of time value of money. Questions about that?
Is that because of inflation? Why are they equivalent?
Not inflation, but interest. So because you know that you would gain 10% interest in your bank account, then if they gave you $1,000 today, you could go put it in the bank, it would get 10% interest. You'd have 1,331 in 3 years. So they could give you $1,000 today, or they could give you 1,331 in 3 years, and they'd be equivalent.
I see. Thank you.
Mm-hmm. And today we are going to talk about nominal versus effective interest. So this is where they get you. They will advertise like the APR. Let's say if you were to buy a car, and get a car loan, they'll advertise the APR, and you'll think that that's like the interest that you're actually paying, but it's not. It's veiled by the fact that your loan compounds more than once a year, right? You're making payments once a month, usually, not once a year. So they'll give you this annual interest rate that doesn't really make sense because it's compounding monthly, not annually, right? So consider an interest period that is divided into multiple compounding periods. Okay, so they give you the rate, which is annual percentage rate, and you're told to consider that as your interest, but that only works because it's assuming that the interest rate and the period, meaning every time they hit enter, right, and the period, it's assuming that they both line up as 1 year. But that's not always the case. So what we need to do is define how to break that up. So we have M, which represents the number of compounding periods per year. How many times do they hit enter and collect interest a year? It's not just once. Now, it depends on the situation, but that's what M stands for, is how many times. So then we can define I sub M as the interest rate per each compounding period. And the way we calculate I sub M is R over M. And we will call this the nominal rate. So we're taking the annual percentage rate, but we're really dividing it by how many times it compounds a year. And that's the nominal rate. Then we can calculate the effective interest rate, which is effectively what the true interest is per year, not the fake one that they advertise to you. And the way we calculate that is we take 1 plus I sub M, and then we raise it to how many times it compounds, and subtract 1. Or, of course, if you just plug it in, it's 1 plus R over M to the M minus 1. Yes, I sub M is R over M.
Professor? Is M is the same M that is in, so it's the capital M, the compounding interest, compounding periods per year, and then there's sub M. Are these the same M's?
Yes. Yes.
Okay, thank you.
Mm-hmm. Okay, so then we can look at it kind of two different ways. We can say, well, let's use the effective interest rate, and now we know effectively how much it's worth or what the interest is per year, and then we can use X amount of years. Or we could go back and just look at the nominal interest rate, knowing what it is per compounding period, and we can use the number of periods, right? They just have to line up. So years and years or periods and periods. So there are two ways to approach these scenarios. The first is the effective interest rate approach, or second is the period interest rate approach. So, for example, if I know that I have a first cost, which is $1,000, but I am told that it compounds semi-annually. What does that mean?
Twice a year.
Twice a year. So M would equal 2. They told me that my APR is 12%. So that is your I or your R when you're plugging things into the equation. They told me that my years is 3 years. So the first thing I would do is say, well, what's the interest per compounding period? So I'll take the rate that they gave me and I'll divide it by how many times it compounds. And I get 6%. Then I can use that to say effectively what's my real annual interest rate. So my real annual interest rate, remember, is calculated by 1 plus R over M to the M minus 1. Or you could look at it as 1 plus I sub M to the M minus 1. So I can say, all right, what should I plug in for I sub M?
0.06.
Very good, 0.06. So make sure it's in decimal form. And then what should I plug in for M?
2.
2. And then minus 1. So what do I get for my effective interest rate?
$12.36%.
Very good. So you would get 0.1236 or 12.36%. So you see, you know, on the big sign by the car, it says APR is only 12%. Woohoo! But in reality, because it compounds twice a year, you're not just paying 12%, you're really paying 12.36%. So it's like this hidden amount that you never knew about. Okay. And so then you can say, okay, well, let's figure out truly how much I'm paying in total. And so you can use your equation f equals p times 1 plus I to the n, like we talked about last time. Because it's compounding, right? It's not simple interest. So this is a compounding interest equation. And you can plug it in. So what goes in for p?
1,000.
And for the interest rate, we're going to use 0.1236 because that's what we calculated. And that is an effective annual interest rate. So we would say we have 3 of those, 3 years. So what do you get?
1418.
So you get $1,418.52. So that is one way to look at it. We had to figure out effectively what the true annual interest rate is because it compounds more than once a year. Then, once we found that out, I effective, we could use that in the equation and use the years to figure out what the total amount is. Now, another way to look at it with the exact same given information would be, instead of looking at it in an overall annual rate, we could look at it as a per period rate. So, and then we could say, instead of using how many years, we're going to use just how many periods there are. So the second approach would be to convert n so that you can use just the nominal interest rate, which is that I sub m, that first number we got, the 6%. So if we want to use the 6% in our equation, which represents just basically the interest per period, then we need to know, well, how many periods do we have? So instead of saying n is 3, we've got n is 3 years, but how many times does it compound per year?
Twice.
So it's 2 periods per year. So that means that we really have 6 periods that we're dealing with over the 3-year lifespan. So we can use the same equation, f equals p times 1 plus I to the n, but now, even though p is still 1,000, we're going to use our nominal interest rate, that 6% that we calculated, that first thing we did, 6%, because that's a per period interest rate, and we'll use how many periods we have. So if you use a per period interest rate, then you have to use how many periods you have, or you could use the effective annual interest rate and use how many years you had. So those are your 2 different approaches. They just have to line up. Think about it like units, right? The units have to line up. What do you get when you plug that in?
Same answer as before.
Same answer as before. So depending on what just makes sense to your brain, it doesn't matter because you'll get the same answer. So you could say, well, let's figure out what the interest rate is per period, and then I'll use how many periods I have. Or I can say, what's the true interest rate per year, and then I'll use how many years I have. But no matter what, as long as they line up, you'll get the same answer. Questions about that?
No.
Andrew says no. He'll speak for everyone. Okay, so let's make note about some of our compounding periods, because we just did one that was semi-annually, but you could run into many different options here. So know your compounding periods. All right, so we already went over semi-annually, which means m equals
2.
Okay, and then what if someone said it compounds quarterly?
4.
4.
What if it compounds monthly?
12.
And think really hard about this one. What if it compounds daily?
It's 360 or something, right?
Something like that. Anyone have the something part?
365.
Close.
It's like it's not the full year. It's something like short of it. I forget exactly.
Anyone know? 365 point a quarter. Yes, because of leap year. Leap year happens every 4 years. So on average, a length of a year is actually 365.25 days. Fun stuff.
Professor?
Yeah.
So it would be a bad deal if I would get a loan that is daily compounded.
Oh, that would be a real bad deal. Yeah.
So you want as less compounding as possible.
If you had a bank account that compounded every day, that'd be great.
Good. Yeah.
That'll never happen.
Hey, you never know.
How would they furnish their corporate jets if they ever made that? No?
So yes, this is what's important. I think honestly, this class could be most applicable to like anyone's life, right? It's not just engineering, because you're going, wait a minute, that's how they get me, right? They just secretly go, oh, here's your APR, but it compounds monthly. Okay, well, if it compounds monthly, then that APR is a nonsensical number. Let me figure out what they're really charging me every year, you know? Or think about it as they're charging me X amount every month, and then it's this many months, you know? So don't get fooled by that APR. Yes. Okay, so the other thing I want you to note is that I expect that you know your algebra. Okay, so I expect that you know your algebra, meaning you know how to like rearrange the variables and solve for any unknown in this equation, not just always F, right? Let's say I wanted you to solve for P, or I wanted you to solve for I or for N or whatever. I'm expecting you to know your algebra to be able to do that. So if you feel like, oof, that's not really my strong suit, you might want to come to office hours, because like I said, I've been tutoring since 2005. Algebra is my jam. Okay, so if you need help with that, I can help you. These equations can all be rearranged to find other missing variables.